Have you ever thought about this idea, write once, run anywhere? It's kind of this core philosophy behind a lot of our digital world, like building something once and then it just works everywhere. There's this one technology sort of humming away quietly for decades that really made that happen, and we're diving into it today.
Java. Yeah, Java. I
Yeah.
know. Newer languages get all the buzz, right? But Java started way back in 95. And believe it or not, it's still incredibly important in 2025.
It really is. And that's our mission for this deep dive, to figure out what Java was really built for, why so many different industries picked it up, and crucially, what keeps it so relevant today. We've got some great source material to unpack here.
Okay, let's get into it. So for anyone listening who's maybe heard the name Java but isn't quite sure, what is it
Yeah.
fundamentally?
So Java is basically a high-level object-oriented programming language, general purpose, class-based. It came out of Sun Microsystems. They're part of Oracle now, way back in 1995. Think of it as a powerful toolkit for building software, pretty much any kind of software. And that famous slogan, write once, run anywhere. How did they actually pull that off? What was the trick?
The trick was its platform independence. See, Java code isn't compiled straight to machine code for, say, Windows or Mac. Instead, it's compiled into something called bytecode.
Bytecode,
Yeah,
okay.
and this bytecode runs on the Java virtual machine, the JVM. The JVM is the really clever part. It's like this layer that sits between the Java code and the actual hardware or operating system. It handles all those underlying differences. So your Java app runs on any device with the right JVM, desktops, servers, phones, even tiny embedded systems. It was revolutionary for reach and cost.
Gotcha. So the JVM is the translator, basically.
Pretty much. And another core thing is its object-oriented nature. That means it uses concepts like classes, objects, inheritance. It encourages building software in modular reusable chunks. Sort of like high-tech Legos.
Right, making complex stuff more manageable.
It's exactly. Easier to build, easier to maintain over time. Plus, it's known for being robust. It has strong type checking, which catches errors early. It has good exception handling for when things go wrong. And automatic memory management garbage collection. That's a big one.
Garbage collection, what does that do?
It automatically cleans up memory that the program isn't using anymore. This helps prevent common nasty bugs like memory leaks that can crash applications. Super important for reliability.
Okay, makes sense. Reliable and manageable. What else?
Security was also built in from the get-go. Things like a sandbox environment and bytecode verification. These help protect systems from malicious code, which was really forward-thinking in the mid-90s when the internet was taking off.
Right.
Made it great for networked apps.
And I heard it has a big library of tools.
Oh yeah, a huge standard library, the Java API. It gives developers tons of pre-built, tested code for common tasks. Networking, file stuff, graphics, you name it. It means developers don't have to, like, reinvent the wheel all the time. They can focus on the unique parts of their application, which speeds things up a lot.
And the language itself, I read it borrowed from C and C++, right? But made things simpler.
That's right. The syntax feels familiar if you know C or C++ Live, but Java smoothed out some of the trickier, more error-prone parts, made it a bit more accessible maybe, but still really powerful. A good balance.
Okay, so that's what Java is. Robust, platform independent, object-oriented. But the amazing thing is just how widespread it became. Why did everyone start using it?
Well, a huge driver was definitely that cross-platform compatibility we talked about, that
Yeah.
WORA, write once, run anywhere promise. Being able to write one code base for Windows, Mac, Linux, later Android, I mean, that's a massive saving in time and money, especially for big companies or anyone targeting mobile.
Yeah, you can see the appeal. And speaking of big companies, Java is everywhere in the enterprise world, isn't it? Like almost unavoidable.
Absolutely unavoidable. Java is dominant there. A big reason is the strength of its ecosystem for enterprise needs frameworks like Spring, Hibernate, Jakarta EE. These frameworks basically provide tested, standardized ways to build large, complex, secure applications. They kind of reduce the risk.
So it became the safe choice for the big, important stuff.
Exactly. Think mission-critical systems,
Mhm.
banking platforms, processing billions, giant e-commerce sites, complex internal business software. Java provided that stability and scalability they absolutely needed.
And closer to home for, well, pretty much everyone listening, Android phones.
Yep. Java's still a primary language for Android development. Kotlin's
Yeah.
popular too now, but huge amounts of the Android ecosystem and countless apps are built with Java. And given Android has, over 70% of the global market share, that means Java's still running in billions of pockets.
Wow. Okay, so it's handling massive enterprise systems and mobile apps. How does it actually perform? Can it handle that kind of scale and speed?
It handles it really well, actually. The JVM is key here again. It uses just-in-time, or JIT compilation. This means it optimizes the bytecode while the application is running, so maybe a tiny startup delay, but then it can run extremely fast, sometimes close to C++ speeds.
Okay, so it gets faster as it runs.
Yeah, essentially. Plus, it has really strong support for multi-threading.
Multi-threading, handling lots of things at once.
Precisely. Like a busy web server dealing with thousands of users simultaneously. Java is built to handle that kind of concurrency efficiently. That's why you see it in things like Apache Tomcat web servers or big data tools like Apache Hadoop. It scales.
It sounds like the tech is solid, but you often hear that the community around a language is just as important for its survival. How's Java's ecosystem?
Oh, it's massive. Absolutely huge. There's an incredible ecosystem of libraries, frameworks, and tools, things like Maven or Gradle for managing project dependencies, Apache Commons for extra utilities, the list goes on. And the community itself is global, millions of developers. They contribute to open source projects, share knowledge on forums like Stack Overflow. It's a very active and supportive environment,
That must help keep it relevant.
definitely. And it ties into reliability for long-term projects too.
Hmm.
Java puts a big emphasis on backward compatibility. That means that code written, 10, even 20 years ago can often still run on the latest JVMs. For businesses with huge investments in existing systems, that stability is gold.
Okay, that makes a lot of sense for its past success. But now the big question. 2025, we have Python, JavaScript, Go, Rust, all these newer languages. Why is Java still so important? What keeps it going?
I think the biggest factor is that it hasn't stood still. Java is under constant active development by Oracle and the community. They release a new JDK, the Java Development Kit, every 6 months now. And these aren't just minor tweaks. We're seeing major features added, like recently things like records to simplify code, sealed classes for better design control, pattern matching to make code cleaner.
And I heard about something called Project Loom.
Yes, Project Loom is a game changer. It introduces virtual threads, which are a much more lightweight way to handle concurrency. This directly tackles one of the areas where newer languages sometimes seemed simpler or more efficient. It makes Java even better for those high-throughput applications that's evolving strategically.
So it's adapting. How about fitting into the whole cloud computing world? Is it keeping up there?
It's adapted incredibly well, actually. Frameworks like Spring Boot are specifically designed for building microservices, those small independent services that make up modern cloud apps. They were great on platforms like AWS, Azure, and run well in containers using Kubernetes. And tools like GrailVM allow Java apps to start faster and use less memory, which is perfect for efficient cloud deployment. So yeah, it's very much cloud native now.
Okay. What about other big buzzwords? Big data, AI. Does Java play a role there?
It definitely does. Many foundational big data tools like Apache Spark for data processing or Apache Kafka for data streaming are actually built using Java or run on the JVM. And in AI, while Python is dominant for, say, model training, Java libraries like Deep Learning 4J are used for production systems, especially within larger enterprise environments. It often provides the robust backend for these data-intensive applications.
Right, it's often the engine under the hood.
Exactly. And then there's the sheer inertia and trust factor. So many organizations have massive critical systems built in Java. Rewriting them entirely is often just too expensive and way too risky. Java's stability and proven track record mean companies trust it for extending and maintaining these essential applications.
And the people factor. Are new developers still learning Java?
Absolutely. It's still a core part of computer science education pretty much everywhere.
Hmm.
Universities teach it because its concepts are fundamental. Its syntax is relatively clear. The object-oriented principles are well-defined. It's a good language to learn on. And because it's taught widely, there's a steady stream of developers entering the workforce who know Java, which keeps it viable for companies. It's kind of a loop.
So bringing it all together, how does Java really stack up against those newer competitors today? People sometimes call it verbose or a bit, heavy compared to something like Python or Go.
That's a fair criticism sometimes, especially historically. But look, while Python is fantastic for data science and JavaScript runs the web front end, Java's sweet spot remains incredibly strong. Large-scale back-end systems, Android apps, complex enterprise software. Its performance, especially with JIT and now virtual threads, is excellent. Its strong typing catches errors that can plague dynamically typed languages in huge projects. And the recent language improvements are actively addressing that perceived verbosity. Project Loon, for instance, makes handling concurrency much less complex than it used to be. It's proving it can stay competitive, even against languages designed specifically for some of those modern challenges.
It really has had an incredible journey, hasn't it? From 1995 all the way to 2025, still a major force. It speaks volumes about its adaptability, that reliability you mentioned, and just the power of its community.
Absolutely. Its versatility is just amazing when you think about it. Android apps, cloud microservices, massive data platforms.
Mhm.
It covers so much ground. And that all comes back to those core strengths: cross-platform ability, the enterprise frameworks, that huge active ecosystem.
Yeah, and its relevance today isn't just coasting on the past. It's those continuous updates. It's role in cloud and data, and the fact that it's so embedded in education and industry, it's just solid.
It really is. And maybe connecting this to the bigger picture, Java's story shows how these really foundational technologies, if managed well, can do more than just survive. They can adapt, evolve, and stay vital for decades. Makes you wonder, doesn't it? What other technologies that seem established today might surprise us down the road by reinventing themselves just as effectively? Something to think about.